Before anyone officially teaches you what engineering is, you've already started learning what kind of person engineering seems to expect. Some expectations are obvious. You're expected to work hard, understand math and science, take difficult classes, and prove you can handle material that actually matters. That part makes sense. Engineering should be rigorous. If people are going to build bridges, write code, design medical devices, or make systems others depend on, the work cannot be easy just for the sake of being easy. But in engineering, difficulty often becomes more than difficulty. It becomes a test of character. You're not only expected to learn the material, you're expected to handle pressure in a specific way. Move fast, keep up, figure things out without needing too much explanation, struggle without showing it, and treat exhaustion as part of the atmosphere. Slowly, the question changes from, can you learn this, to, are you the kind of person who can survive this? That is what Cassie Walway and her co-authors call engineering's exclusionary weed-out culture. In their article, they describe weed-out culture as the belief that certain courses or experiences remove students who are supposedly not cut out to become engineers. What matters is that they do not frame this as only a grade problem. Exclusion also happens through competitive classrooms, unwelcoming environments, lack of belonging, and the feeling that struggle reveals something extremely permanent about you. Weed-out culture often sounds neutral because everyone has agreed to call it standards. Be fast, be tough, be independent, do not need too much help, do not fall behind, and do not let the pressure show. Over time, those expectations start to define what engineering success is supposed to look like. Weed-out culture is not just about hard classes. It is about the kind of person those classes seem to be looking for. And once you notice that, the next question is not just what engineering expects, but who those expectations sound like. The traits engineering tends to reward do not feel random. Speed, independence, competition, confidence under pressure, mathematical ability, emotional control, and the ability to keep going without much support. These are treated as engineering traits, but they also exist outside of engineering. They show up in how we talk about personality, ability, discipline, and gender. The NIH article, The Genetics of Sex Differences in Brain and Behavior, look at sex differences in the brain, behavior, and psychological traits. It discusses differences observed between men and women, while also pointing out that some differences are shaped by environment. So I'm not saying these traits are fixed, natural, true for every person. I'm interested in which traits have historically been associated with men, whether through biology, socialization, expectation, or reward. In the article's section on psychological and behavioral sex differences, some skills, like spatial tasks and mathematical problem solving, are discussed as areas where men have often performed better on average. Other skills, like verbal fluency, articulation, verbal memory, and certain language tasks, are discussed as areas where women have often performed better on average. The field rewards the person who is mathematically confident, technically focused, independent, competitive, and controlled under pressure. Those traits have long been attached to masculinity, expected from men, trained into men, or recognized more easily when men display them. That does not mean only men can have these traits. It means these traits have often been made more visible, more expected, and especially more rewarded in men. Engineering did not form in a neutral room where everyone arrived at the same time. For a long time, the people most visible in engineering spaces were white men. They were the students in the classrooms, the names in the textbooks, and the people in the labs, and the examples used to show what engineering success looked like. The first people recognized by a field do more than just succeed inside of it. They become the blueprint. Their habits start to look like discipline, their strengths start to look like technical ability, and their way of working starts to look like the natural shape of the profession. But this leaves an uncomfortable question. Were these traits really engineering excellence, or just the version history chose to remember? Some people may say this is overthinking it. Maybe those traits became dominant because they worked. Maybe if other ways of thinking were useful, they would have influenced the field too. But that assumes good work always gets recognized. Rosalind Franklin's story shows why that is not true. Franklin was a chemist and expert in X-ray crystallography. Her work was slow, precise, mathematical, and especially evidence-driven. At King's College in London, she studied DNA by taking X-ray images of its structure, including the image now known as photograph 51. This image became one of the clearest pieces of evidence that DNA had a helical structure. Her approach was extremely cautious and very exact and deeply analytical. But her method, the method that helped make the discovery possible, was not the method that became famous. Franklin's photograph was shown to James Watson without her knowledge or permission, and Watson and Crick's model relied heavily on her data. They became the public story of DNA structure, while Franklin's contribution was pushed aside. That matters because a field integrates the stories told about those discoveries. If slower, more careful, less traditionally celebrated work is erased from the story, then its method is erased too. And once that method disappears, it becomes easy to say it was never important. Franklin is not the only example. NASA has its own version of the same exact problem. In the story of the space race, the image most people remember is usually male: astronauts, engineers, men in mission control, and men beside rockets. But behind that image were women whose calculations made those missions possible. Katherine Johnson, Dorothy Vaughan, Mary Jackson, and many other black female mathematicians worked as human computers for NACA and NASA. They processed data, solved equations, checked trajectories, and helped turn spaceflight from ambition into something that actually happened. Johnson's calculations were trusted enough that before John Glenn's 1962 orbital flight, she verified the results produced by electrical computers. Dorothy Vaughan led the West Area Computing Group and taught herself programming as NASA moved toward machines. Mary Jackson became NASA's first black female engineer in 1958 and later worked to improve opportunities for women in science, engineering, and mathematics careers. Their work was technical, precise, and necessary, but it was not the main image of NASA. They were inside the room doing the math, and yet they were still hidden behind the public picture of who engineering belonged to. So when someone says different ways of working would have shaped the field if they mattered, NASA gives us the answer that they did shape the field. They were just not always allowed to shape the story. And if women weren't allowed to do this, then they weren't allowed to shape the stereotype either. By the time more women were allowed into engineering, the room already knew what intelligence was supposed to sound like and what confidence was supposed to look like. That idea had been built around the people who were there first. That is why stereotypes matter. They become standards. They decide who seems naturally technical and who has to keep proving they belong. And this is not only in engineering. It happens in classrooms, hospitals, offices, labs, and boardrooms, anywhere successes were defined before everyone was allowed to participate. If we do not question those inherited ideals, we keep missing the people who think differently, work carefully, ask better questions, and notice consequences others ignore. Engineering is supposed to build things people have to live with, so it needs perspective and it needs empathy. Access is not the same as inclusion, and if engineering is supposed to build the future, it cannot keep using the past as its blueprint.